theorem, then we'll talk about the Cassandra. Okay, let's first move to the cap theorem. Okay, why I'm talking about the cap theorem, because then you'll understand Cassandra in better way. The cap theorem says that in order to achieve something, you have to jeopardize something, or you have to basically compromise with something. And what is that something? Is that, so there are three aspects of any application, is called the consistency, availability, and the partition tolerance. Okay, what happens in the case of a consistency, what happens in case of availability, and what is the partition tolerance. So let's talk about the cap theorem and why any applications can have only two of this. Okay, so whenever we are selecting any NoSQL type of databases, we always think about what kind of a thing we want, right? So the consistency means, again, we have already talked about so many times now, the consistency means that all the reads receive the most recent write. So it is all reads receive the most recent writes. I'll save the notes as well, so don't worry about this. I'll be anyway sharing the document just like I shared for the cache and all. So I'll share for the cap and all the master slave architecture we have discussed, even with the diagrams and all. Okay, availability. Okay, so what it means is that all reads contain data, but it might not be the most recent. It will send, but it might not be the most recent. Then comes the partition, P. Okay, the partition tolerance says the system will continue to operate despite network failure. Okay, so let's understand it. Like, network failure means there are three nodes, one node went down because of so and so, the system will still continue to work. Okay, now, so any NoSQL databases, when you select, you'll have to basically tune it or select the database accordingly by thinking about these three aspects. And what it tells is, it tells that if there is a partition tolerant happen, if there is a situation comes in that one of the node goes down, you can choose only two things. You can either make it more available, then your consistency will be compromised. If you want more consistency, your availability will be compromised. You cannot have both the things when the network failure happens. And that is why you might be seeing the cap theorem always shows like a triangle. And that's why you will see that. Okay, so what it says that, okay, that if there is a partition tolerant happen, if the partition failures happens, we'll talk about what partition tolerant means again, then you can either have the availability or the consistency. Let's understand this. Okay, so you have three nodes. So all are in sync, all are working fine. You are able to read write from any place. You can do a read write here, you can do a read write here, you can do a read write here. So your applications, once suppose right here, then it will basically sync up with other two nodes, and the other two nodes will also have the same information, and you can do a read from here, write from here, read from here, write from here. All are fine, absolutely no issues. Okay, now there is a network failure happened and the communication this is broken. Now this node is out of sync, which means we are talking about P now. Now what we can choose here, right? Now if you are going with availability, if you are telling that, hey, I want my cluster to be still up and running even if one node goes down, because for me this is the entire cluster. I can connect to any of this. So this is my cluster, and I say that, okay, I want to choose availability. Okay, I want to say that availability means that if one of my nodes goes down, I should be still able to continue working it, like the read write should go. So what you will do, read write should go, that's perfectly fine. So you are choosing the availability. Now what will happen is, the first thing is that whatever the write which was happened here, correct, that suppose is not yet reflected here, that kind of information you will not get. That is the one problem. So you're compromising the, so there was one update, suppose the username was updated from X to Y, correct, and this was not replicated before it died. So what happened is, this guy still have X and X. So if you do a read, you will still get the X only, but your system is available. That is what I was telling that time, right? So availability means all read contains data, so it will get the data. That fine, your username is X, but it is not the recent one. It hasn't been updated because that died. That is the one thing. Second is that you are maintaining some transactional related data, like you have basically you are maintaining balance or account. Suppose accounting which gets reduced from every time operation happens, count starts 99, then 98. I was giving a hypothetical answer, question here, scenario here. So that count initially was 100 on each node. Okay, now what happened is, we did one round of operation, and then now count has gone down to 99. All things are working fine because all are in sync. Now what has happened is, this guy died. This guy died at 99, and then we continue operating here. So this has become now 97, 96. This also become 97, 96. Oh, sorry, 98 was also there. So now we are at 96, 96 here on both the node. But this node, when it comes up, right? When it comes up, before it catches the information with this guy, that okay, what was your update? Because it's not only one data. It would be that this node was down for a minute, and in between there is like thousands and thousands of update has come into this place. Before this guy using the gossip protocol comes that okay, I have to sync up with the data. As you made this node available, you will start responding to that guy that okay, hey, my node was 99. Somebody did a read and they say okay, 99, and then you will have an inconsistent state. One is saying 69, 96, one is saying 99. So you are compromising the consistency here at the luxury of getting the availability. Now you might be wondering why somebody will use such kind of application, and you will be really, I'm not sure whether you guys are aware of it. Facebook extensively uses these kind of concept. Twitter uses these kind of a concept. Any maximum social networking companies, they use this because they don't care much about the consistency. What if you don't see the new post posted by a user immediately? What if you don't see the real update or most updated data on the page? What if you don't get the latest comments from somebody user out of 1,000 updates? They don't care about much about that. What they care about is when you open facebook.com, it should load, it should view all the informations what you are. Even though it's little stale data, that's perfectly fine. They can compromise on consistency, but they will not compromise on availability. They never want their sites to be down. Okay, so these kind of companies. So you wanted the real use cases. These are the real use cases where people use it for that. Even for the monitoring kind of data, they use these kind of things because they want it more and more availability. Now let's talk about the how. If we choose the the consistency, how the availability will compromised. Is there any question in that, guys? Just we discussed that. So there is a partition tolerant happen. The partition failure has happened, network failure happened, and this node goes down. Okay. Now I want to choose the consistency. I said, hey, no, I don't want to compromise on consistency. I want the consistency to be done. So what you will do? You will make your entire cluster unavailable, right? You will tell that, hey, one of my node is down. Okay, so unless that node comes in, I will not be taking any request until unless this comes, because whatever read or write you do here, that will not be in the sync. And once that node comes in, we will be in highly inconsistent state, and we have chosen the consistency. So we will not be able to serve you any traffic until unless this node either gets replaced or fixed or whatever. Then only I'll make sure myself available. So what you have caused here, the cost is the unavailability, because you are choosing the strong consistency. You want your system to be consistent, then your availability will be compromised. This is what the CAP theorem, the famous CAP theorem, and you won't believe that. I mean, I'm not sure how many of you have taken the interviews. This CAP theorem gets discussed in almost 80 to 90% of the interviews. Whenever you talk about that, this trade-off, the trade-off of choosing the consistency over availability or availability over the consistency, is one of the most discussed topic in any system design interview. Okay, so just go through. I'll share a few more details, and there are various configurations you can do. So in Cassandra, okay, I'll tell you what Cassandra achieve is something like they have a concept like a quorum. Okay, so they have each quorum, local quorum. So what the way it works is, so you can configure the Cassandra. I'll give you one pretty good document or walkthrough sometime later. So the Cassandra does is that there are configurations you can do as each quorum, and then there is a local quorum. Now, what does it mean? The quorum means is that if you want to achieve the strong consistency in Cassandra, you configure your query database in a way that you say that, okay, I want to have each quorum. That means if you do a write to one node, and if you say that each quorum means how many of the nodes are there, whatever the nodes are there in the cluster. There are suppose total 4 nodes. So you got a request, write request on this node. You will send a request to this node. Hey, you go ahead and write this. So ID equal to 1. It will also write ID equal to 1. It will also tell that, hey, you also write ID equal to 1. ID equals to 1, and you send me the response that you have written. So until unless all these 3 confirms that, okay, they all 3 have written successfully, then only it will say success. Okay, so if you want to achieve the strong consistency in Cassandra, people use each quorum, and then they said that, okay, if any of the node doesn't respond to back, you don't reply. That means you are compromising the availability, correct? Because what will happen if this node goes down and you are writing, you are trying to insert a data with each quorum policy. They call it policy. If you're using the each quorum policy, this node, the node which got the request to write, it will tell that, okay, I have 3 nodes cluster, right? 4 nodes cluster. So there are 3 nodes I need to send that request to, and it will send all these 3. If any of these are unavailable, it will not respond back. It will say that, okay, failed. I'll not be able to write it. That means we compromised availability at the cost of consistency. Okay. Then there is a local quorum. Local quorum is the least consistent thing, where you say that, okay, I have locally I've created. So you asked me to write it. I have written it. I'll send the success response to you. I really don't care whether these guys have got the data or not. What if I die here? These guys will not have any data, and that will lead to the consistent, that will lead to a weak consistency. That means you don't have the latest update what it was there here, right? So suppose you say that ID 2, and you are sending with local quorum, ID 2 will be stored here, but before these guys do a gossip protocol with each other and get the data, this guy died, ID 2 is not present here any of the node. That means it is a eventual consistency. Then there is one more intermediate, this one where you want to balance things, like you just want to play safe. In that case, I forgot the name. There is a each quorum, local quorum. Do you guys know about the third one, where you can provide the how many nodes you want? Like, it will make sure that other than this node, either 1 or 2 nodes also gets the update. Not all the nodes, but 1 or 2 nodes also gets the